diagram, if I say P, Q, R, S, T, then diagram. If I say S and P are the midpoints, then ST parallel PQ and ST equal to half of PQ. If these are midpoints, then ST parallel PQ and ST equal to half of PQ. Now, converse of midpoint theorem. Converse of midpoint theorem. Converse of midpoint theorem. Converse of midpoint theorem. Here I am not taking the proof of this theorem, just explaining. Suppose you have this diagram. Triangle ABC. And if you are given P is the midpoint in triangle ABC, P is midpoint of AB. Okay? And through this midpoint, if you draw a parallel line, PQ, parallel line PQ parallel BC. From the midpoint of one side, if a parallel line is drawn to other side, then it bisects the remaining side. That is, this bisect this side. Therefore, you get AQ equal to Q. That is the theorem. That is converse of midpoint theorem. From the midpoint of any one side, if we draw a parallel line to other side, the remaining side. That means this Q divides AC into two equal parts. That means Q is the midpoint of remaining side. It bisects the other side. That means AQ equal to QC. That is converse of midpoint theorem. Now, based on this midpoint theorem and converse of midpoint theorem, we have to solve questions depending on high 0.5 based on these theorems. High 0.5. So here, let's start practice set 5.5. Practice set 5.5. First question is going to you. Question first. A, B, C, X, Y, Z. In this, you have given that X, Y, Z are the midpoints. AB equal to 5, AC equal to 9, and BC equal to 11. These values given to you. Find the length of XY, YZ, and XZ. You want to find out XY, YZ, and XZ. So first of all, for XY, forget this. In triangle ABC, P is midpoint, X is midpoint, not P. X is midpoint of AB. Okay? And Y is midpoint of BC. Therefore, by midpoint theorem. So what is the midpoint theorem? Line segment joining midpoints of any two sides is parallel to third side and half of it. Here we don't want parallel, we want half. So this XY, therefore this XY is equal to half of this one AC, half of AC. So here, therefore XY equal to half into 9, that is equal to 4.5. We got first answer. In the same way, for YZ, and Y is the midpoint, Z is the midpoint. So in the same way, also Therefore, by midpoint theorem, line segment joining midpoints, that is YZ, is equal to half of the third side. So YZ parallel to AB and half of AB. So YZ equal to half of AB. So here YZ equal to half into 5, that is 2.5. We get the value of YZ. In the same way, third one, forget it. This one, X is midpoint of AB, Z is midpoint of AC. Therefore, by midpoint theorem, XZ equal to half of BC. Here is a midpoint theorem. So here XZ equal to half into 11, that is 5.5. So in this way, we got all the three values one by one by using midpoint theorem. Now, question 2. Question 2. You have such a diagram. L, M, L, P, Q, R, S. So in this quadrilateral PQRS and LMNR, both are rectangles. Both are rectangles. And you have given that if point here is the midpoint, both are rectangles, you have given point here is midpoint. Then prove that SL equal to LR and LN equal to half of S2. So we have to do it one by one. To prove, here I am not writing given. Here we want to prove SL equal to LR. And then you want to prove LN equal to half of S2. Half of S2 that you want to do. Okay. So let's start the proof. First of all, I use this quadrilateral. This quadrilateral. I use this quadrilateral. Quadrilateral MNR is rectangle. So as with rectangle, opposite sides are parallel. Therefore, LM parallel RL. Okay, opposite sides are parallel. Now, for a while, consider this triangle. This one. Consider this triangle. Also, along with that, and I will use further LM equal to R. LM equal to R. Okay. Now further, in triangle RPSR, in triangle PSR, check this triangle PSR. Now check half portion. What is here? Check your given part. Here is the midpoint of PR. Here is midpoint of PR, which is given to you. Given. And this LM parallel RN, that is just good. So from the midpoint of one side of triangle, if a parallel line is drawn, then it bisects the third side. So this LM by converse of midpoint theorem. Converse of midpoint theorem. It bisects third side. It bisects. Yes, R. Therefore, SL equal to LR. By converse of midpoint theorem, it bisects third side, so it is SL equal to LR. Okay. That means you can say here is the midpoint. That means here is midpoint of SR. So here, by considering this upper portion, here is the midpoint, ML parallel, so here it bisects, that means SL equal to LR, so here is the midpoint. In the same way, if we consider this portion, in the same way, and forget this portion, so here LM parallel RM, and here LR parallel MM. Both pairs of opposite sides are parallel. Okay, LM parallel RM and this LR parallel MM. So here, as LR parallel MM and this LR parallel to PQ, as this is a rectangle, opposite sides are parallel. This SR parallel PQ and MN parallel LR, so that is MN parallel to PQ. So indirectly, in the same way, here is the midpoint, MN parallel PQ. So it bisects this third side. In the same way, you can prove that L is the midpoint of RQ. Similarly, we can prove that. N is midpoint of RQ. Here is the midpoint of RQ that we can prove. Now, further. Now, I draw complete diagram again. Forget this middle line. Now, what you want to put ln equal to half s cube. Join ln, and that is yes. Here, forget this portion. We got triangle SRQ. In triangle SRQ, L is midpoint of SR. L is midpoint of RQ. If both are midpoints, therefore by midpoint theorem, by midpoint theorem, line segment joining the midpoint is parallel to third side, that means Ln parallel to S cube. We know what parallel, and then Ln equal to half of S cube. Ln equal to half of S cube. That is the required proof. Question number 2. Now, let's proceed further. We will solve next 2 questions. Now, question number 3. Question number 3.